Okay, I think we are live. Hello everyone, and welcome to this live event. My name is Angelo Manataka. I'm a cloud engineer and AWS community and one of organizer of the AWS Netherlands user group. And today with David, I will host this event. David, nice to meet you. Nice to have you here.
Awesome to be here, Angelo. And I just want to say, yeah, I've been looking forward to this the whole week. It's like, I think, a great way to start a Monday, especially if you've had a couple of the Mondays like I think we've been having at the beginning of this year. So really looking forward to it.
Okay, as you read on our webpage, on your website, and also on Meetup page, today's agenda includes 3 great speakers with very interesting topics. If you have any question, of course, leave a comment at the end of each speech. Our speaker will answer you. So let's get started. Our first speaker is Michael Whittick. Michael is the co-founder of Whittick, which is a consulting company focused on cloud architecture, DevOps, and software development on AWS. Together with his brother Andrea, is the author of the book Amazon Web Services in Action, which I used to prepare for my AWS Solution Architect certification, and run the blog cloud.nl, where they share their knowledge about AWS with the community. So welcome, Michael.
Hi, and thanks for the introduction. And I'm very happy to hear that you actually are a reader of the book.
Yeah.
So that's very cool.
Yeah, it was really useful for me. It helped very a lot. So thank you.
Yeah, that's great.
Okay, so Michael, if you want to share your screen.
Yes,
sure. The audience is yours.
Yeah, thank you very much. So I'm going to talk about how we can, in an event-driven system, generate CSV reports. And this is actually based on a real customer requirement that we received. So I will kind of provide or present the topic in a generic way, but I will also kind of use this example as the kind of reference for why I actually try to do that. So yeah, we will go into a specific use case here that I actually implemented. So that's the background. All right, so we already talked about Cloud or not, so let me skip that quickly. So it's a website that you can visit where you get blog posts about AWS, and also we have a podcast. So if you're interested in AWS, which you are likely are, because you joined this meetup, so you can check that out. And now let's start with the topic. So when I talk about an event-driven system, I have 2 kinds of architectures in mind. And the first one is what I would call the more traditional approach, and it is traditional on AWS approach. So if you are not yet so used to AWS, this might not look very traditional to you. But if you are used to AWS, then that is the traditional approach. Both approaches are equal. There is no better or worse approach, but I will just show you both of them. So in an event-driven system, we usually have some kind of message queue at the beginning. In this case, it's an SQS queue. So the SQS queue receives a message from a producer, and then we have a consumer on the other end that reads messages from the queue at its own pace. In this case, it's a fleet of EC2 instances. They are auto-scaled in an auto-scaling group. So depending on the number of messages we have in the queue, we can add capacity and we can also remove capacity, which is helpful to get costs under control. And those EC2 instances do something. In our case, like the product that we develop, they will scan a file on S3 and see if there's a virus or malware or something in the file. And once they are done with the scanning, they publish the result on an SNS topic. And the SNS topic is, again, like a service on AWS that is event-driven. So you publish an event and subscribers can receive those events. So that's one of the architectures that I have in mind when talking about an event-driven system. So a message arrives in the system, it is processed, and then the result is published to another component where we then again have subscribers and so on and so forth. So this chain can repeat a couple of times. A more, I would say, modern approach, or more serverless approach is we start, for example, with a Kinesis data stream. So this is again like an entry point into the system. Messages are put onto the data stream. And then we have a Lambda function who consumes the messages from the stream. And again, once the Lambda function is done with whatever it does, so it maybe does a computation, it maybe does some analysis of the data, it maybe does some enrichment of the data, it does whatever it is needed for your business to kind of make money usually. It then publishes this result, for example, on an event bus. So that is, again, like one of the options that you have to kind of distribute events in an AWS account. So that's what I have in mind. But both those approaches have one thing in common. There are events coming in from one side, they are processed, and then they are kind of pushed out at the other side. So usually events flow through the system. But when we talk about a CSV report, things are a little bit different. What we want, or what our customers wanted, is they want this file where they see basically all the events in one place. So they want a snapshot of all the events that happened within a specific time frame. And that's kind of the challenge. And it is a very generic challenge. And so it doesn't really matter what's the content of your event. It is more about turning an event stream into like a snapshot of the events that happened during, for example, a specific time interval. So that was the problem that we were focused with. So our customers were asking for this, and we provided an architecture that was not really prepared for something like that, because we have kind of a fire and forget architecture. So we didn't store any of the events. So I was very happy actually to come up with this solution for the problem, because it turns out to be, I would say, quite, or at least everything was provided by AWS for me to solve this problem without much coding. And that was very cool. And I was not actually expecting it. So I was surprised. So what we do is, in the system that I have in mind, we start with an SNS topic at the beginning. So not an SQS queue, but an SNS topic, but that doesn't matter. And we subscribe to that SNS topic with a Kinesis Firehose delivery stream. And the Kinesis Firehose delivery stream is one of the central pieces of the architecture. It turns an event stream into chunks that are then delivered into an S3 bucket. So it produces larger files on S3. So not every event is put onto an S3 bucket, but like chunks of events are put onto S3. So that's the first important step of the architecture. And the other important step of the architecture is that we then use another service called Athena to kind of aggregate all the files in the bucket into one CSV report. So that's the job of Amazon Athena. And with those two services, we can basically solve the problem already. And what I did to make it a little bit more user-friendly, I also added a step function state machine that is triggered every day, for example, by an event bridge rule. And this then runs the queries. And at the end, I run the Lambda function to kind of generate an HTML email and send out a nice looking report. But that is kind of optional. So like everything on the right side is optional. The core piece of the architecture, and this is what we are going to have an in-depth look at now, is what you need to turn events into CSV reports. So we are going to look into each of those components now and understand how they work and why they are needed. So let's start with Kinesis Firehose. As I mentioned, Kinesis Firehose turns a stream of events into chunks of data that are delivered, for example, into an S3 bucket. So Kinesis Firehose can deliver into other destinations, but that's not important for us. We are only interested in the S3 use case here. And you can configure the most important like knobs to turn are two configuration options. One is the interval in seconds that chunks are delivered to S3. And you can configure this up to 900 seconds, which is 15 minutes. So every 15 minutes, all the incoming events during that time frame are then pushed onto an S3 bucket in one single file. The other value that you specify is how large this file gets during the 15 minutes. And the maximum value here is 128 megabytes. So every 128 megabytes or every 900 seconds, the file is flushed to the S3 bucket. And you can, of course, configure those values. You can have a shorter interval. You can have smaller files if you wish. And so those are the maximum values that you can use. And I use the maximum values in my use case. The other useful feature, which is not kind of super important, but it helps you to reduce costs a little bit, is Kinesis Firehose can also compress your data. So for example, you can gzip all your data, which kind of reduces the size depending on your data, it is easy to reduce it by 50% if it's JSON or something like that. So that's really handy. And I use that to kind of make sure that the data in S3 is as small as possible. So the question is, how can we connect the SNS topic with Kinesis Firehose delivery streams? And the cool thing here is that this is actually a native subscription type. And this was released a couple of months ago. And I was actually looking at this a couple of weeks after the release. So I was very happy that this existed because it kind of saved me from creating a Lambda function that does its own ingestion into the delivery stream. So it's all integrated into the SNS service. You don't have to do anything. You can configure it, and that's it. And if you are familiar with Kinesis data streams, there's one important thing here. A Kinesis Firehose delivery stream does not have the concept of shards. So you don't need to provision shards up front. You have to do this with a Kinesis data stream. It's not needed here. So it's super easy to kind of create because you don't have to think about the capacity up front. Of course, as always, limits apply. So check out the limits section in the documentation if you're interested in the upper limits. But for, I would say, most use cases, this is like large enough and to just work. So in my case, the limits are just way higher than what I need. So no problem at all. All right. So let's look at the second component that is important for our architecture, and this is Athena. So what can Athena do for us? So you can think of it as something where you put an SQL query, like a SQL query, into Athena, and then it runs the query against data stored in S3. And the data could be in JSON format, it could be in CSV format, it could also be many other formats that are supported out of the box, which is a great fit for us because my events are JSON events, and so it automatically works. So there's nothing for me to do here because Athena already understands the data format, right? That's very cool. One problem with Athena is that to actually read the data from the S3 bucket, we have to specify a schema. And the schema works a little bit different than what you might know from your relational database, where you create the schema up front and then you insert data. With Athena, you create the query, you create the table schema when you read data out of the bucket. So you can basically store whatever you wish in your S3 bucket, and then you define a schema and then read the data based on the schema from your S3 bucket. So it's a little bit different. You cannot really guarantee that the data looks like you think it will look like, but that's something to consider here. One great feature of Athena, and this is very handy for me because I want to generate CSV reports, is out of the box, Athena stores a result of a query as a CSV file on an S3 bucket. So basically the requirement is already kind of implemented by Athena. So I have nothing to do with all this storing the result on the S3 bucket because it's already done by Athena. So that's a great fit. I was very happy to see that when I was reading the documentation. So the only problem, or the only kind of challenge, I would say, in this whole game is that you have to come up with the Athena table schema. And that's why we have a look at it, how it works. So there are multiple options how you can get the schema. And I think the easiest option, and also the option that I went with, because it's also like the one that requires least effort, you collect some data in your S3 bucket. So for example, you wait 1 day or a couple of hours, depends on how many data you receive. And then you use a feature called a clue crawler to detect the schema. The clue crawler looks into your S3 bucket and it kind of determines the schema of your data, which is very handy because then you don't have to do this on your own. And then you can later inspect the create table command that was issued by the crawler, and you can get all the information that you need about the schema. So let's look at how this works. Let me switch into the AWS console. And we will start with the S3 bucket, and we will have a quick look at how my data is stored. So let's open the S3 console, and I will make sure that you can read that. All right. So the bucket that I have prepared with data is called the reporting bucket. Yeah, that's it. And within the data folder, I have all my data. And that's, is this today? No, that's not today. Okay, let me see. I was expecting to see something from today here. Not sure why it's not working. All right. So still we have some data in here. As you can see, those are gzip files. So that's done by Kinesis Firehose. So it gzips our files, and as you can see, there are 2 files in here, so not that many. So that's how our data structure looks like. So important part here is that I have a certain data structure, like folder structure. So I use the year, the month, and the day as a folder, and that helps Glue a little bit to kind of understand the data structure. But besides that, those files here are just delivered from the Firehose as they are delivered. So there's nothing changed within that files. There's no transformation going on or something from my side. All right. So what else do we need? We need a Glue crawler to detect the schema. So I will switch into the Glue service quickly. And you will use like a couple of services here to achieve your goal. So that's kind of I would say, like if you're using this first time, that's, I think, the challenge, that you have to combine a couple of services to get the job done. But I think that's also good exercise in AWS, because usually in AWS, you don't only use a single service. You have to combine multiple services to get your job done. So let's look into the crawlers. So I will make this a little bit larger. Okay, so that's also one thing. As you can see, the UI is a little bit buggy, so it doesn't really hide the navigation bar. So you will see some errors in the UI here, so I will highlight them whenever they happen. But we can hope that this is fixed at some point in time. So let's specify name for our crawler. It doesn't really matter. We will go with the defaults here. Also go with the defaults here. And this is more or less the most important part here. This is where we configure the S3 bucket where the Glue crawler looks into. So I look into the reporting bucket data folder. Yeah, that's correct. Okay. So that's the bucket that I was showing you earlier, and that's the folder within all the data is prepared. We go with the defaults here. I will choose an existing IAM role. You can also create one using the UI, so you don't have to kind of come up with the value add a magic policy yourself. So it is kind of prepared by the UI. And then we can like click on next, on next, on next. I have to create a database here. I choose the default database. That's okay. All my tables should be prefixed with demo, just to make sure that there are no kind of overlaps with the table names. And then finally, I can click the finish button. So what happens here is that now once I click on run crawler, the crawler will start working. It will look into the S3 bucket, and it will generate the tables for me based on the data that's in the S3 bucket. So I also have one prepared here. Now, this is one of the UI features that I highlighted. So this is like all kinds of things go wrong here. So just ignore the errors, reload the page, and things will look great again. So there are kind of bugs in the UI. So that's it. We have to deal with it. All right. That's all you have to do. The crawler will take a couple of minutes to complete. So that's why I created the demo one, the preparation one, because then we don't have to wait for that minute. So let me quickly look at the Athena service, right? So that's the next service we have to use. So sorry, this is the last service that we need to get to the CSV report. We have the demo prep data table. So this is the table that was discovered by the crawler that I prepared before. So I will specify the month and day here, and I will show you how it looks like. So let me hope that there will be some data returned. Yes, okay, great. So this is the query that you run. So let me enlarge this a bit. So it's a SQL query. I mean, it's SQL more or less. I would say the vast majority of features are working. If you're interested in the details, then you have to check out the documentation. So there are a couple of additional features, of course, that you can use here. But basically, it is a SQL query. So it's a select query. You select from a specific table, then you can make some conditions here, and you can limit the amount of data. You can also sort and group and stuff like that. And what you get back is a table. And the cool thing is that you can, as I mentioned, automatically download this as a CSV file. So all the results that are generated by Athena are always a CSV file that is stored on an S3 bucket. So all you see here is basically the UI looking into the file in the S3 bucket. So there's nothing magic that is going on here to present you the data. So out of the box, you have the CSV report, which is pretty cool. So let's look at the schema that was actually generated. So I use this command here. And the command is show create table. So that kind of provides us with the query that is needed to create a table. And as you can see, there's lots of things to type here. So if you really have to create this schema on your own, like manually, I mean, there are many things to kind of get wrong. Many magic values. So for example, I mean, things like that, it's more or less impossible to kind of create this manually. So that's why I recommend using the glue crawler, because the glue crawler does all of that for us. It generates this kind of magic create table statement. So that's why I would recommend using it, because it's, I don't know if it's possible to create this manually. It definitely will take a lot of time to get it right. So what I do suggest is that you can take this query here and then you can modify it. I mean, that's always easier than starting from scratch. Is just use this and then modify it to your needs. All right, so that's all you need. Now you can generate a CSV report by running a Athena query. And of course, because it's an AWS service, you can not only do this from the UI, you can also do this using an API. So you can trigger that over the Athena API, and then you get your result in or you can automate the process of getting the CSV file. So one thing, like one kind of warning that I want to add here is evolving a schema with the glue crawler is a little bit risky, I would say. So that's why I usually do it like this. I use the glue crawler in my test or staging environment, and then I use the create table schema, like I copy it and I apply it to my production environment. I don't use the glue crawler in production. Because what happens if a new attribute is added? What happens if an attribute is removed from your data? I mean, you can configure the glue crawler in different ways. You can just ignore it. You can only add things. You can create a new table name, all kinds of things. But it's always scary when the schema changes, because your queries also have to change. So that's why I recommend not to evolve the schema in production automatically using the glue crawler, because you always have the risk of the data format is changing that's coming in. So yeah, I don't do that. One other important part is understanding how Athena works. So if you run a query like that, so we select from a table and we have some where conditions, and we have a data structure or data folder structure like this. We have the year, within the year we have the month, and within that we have the files. So what you might expect is if you run this query, I mean, by using your human intelligence, you only would look into the 2021 02 folder, right? I mean, we wouldn't look into all the other folders because we're only interested in the February data. What Athena does out of the box, it looks into all the files. It just scans all your files in the bucket. And this is very expensive because you are charged based on the size of data that you kind of look at. And it's also very slow because you always walk through all the files. So that's why you need partitions. And with a partition, Athena actually figures out to only look into the correct folders. So this is very handy and this is very recommended. The question is, how do you get partitions? And the easiest way to get partitions is using, again, the glue crawler, because the glue crawler doesn't only detect the schema, it can also detect your partitions. So let's quickly look at how this works. So we go back to the glue console. There we have this little tables navigation item. And then we look into the demo prep data table. And there you have the, oops, where are my partitions? Okay, now I'm a little bit embarrassed because I don't see partitions. Let me see here. A few partitions here. Okay, as you can see, there's only a single partition here in my table. But like if you have more of that, you will see more partitions. So that's very handy because it speeds up your query significantly. All right, so let's go back to the slides. So last question, what about the cost of this architecture? The cool thing is that SNS, you pay for the events that are processed. So the subscription is charged based on how many events are pushed through the system. So if nothing is pushed, you pay nothing. Firehose, you pay for the processed gigabytes. With S3, you pay for requests and the stored gigabytes. And with Athena, you pay for processed gigabytes. So I'm very happy to kind of label this solution as serverless because you don't pay for idle. You have to provision nothing up front. So this is all completely scalable, like auto-scaled by AWS. So that's very cool. I like that a lot. It's very convenient to operate this solution. So a quick recap. This is how the architecture looks like. We have an SNS topic at the beginning, and this could be anything else. This could be a Kinesis data stream. This could be an IoT rule. This could be CloudWatch logs. This could be Event Bridge. You can exchange this with any other service that can kind of accept or ingest events. Then we have the delivery stream. It turns events into files on S3 in chunks. And then we use Athena to query it. And if you like to make things a little bit more like user-friendly, you can like add something around it and trigger Athena programmatically, for example, with a step functions, which has native support for doing that and also waiting for the result. And then your Lambda function can generate a nice looking email report and send that out using SES, for example. So that's it. That's all I have. That's my little architecture. And I'm very happy that it is so I would say convenient to turn any event stream into a CSV report on AWS. That's it. If you have any questions, then now it's the time for asking them.
That was great, Michael. Thanks. I literally have a ton of questions myself personally. I see like our chat, we haven't really like picked up any here, but I'm sure I can maybe help those guys along a little bit. There's so many things I can think of there. So one, wow, that SNS subscription thing, I didn't even know that. So that's a great learning. Thanks. I don't know if you knew, did you see SNS like can now do like 1 GB messages? So they've upped the size for like the actual, what you can put on like your SNS like topics anyway, right? Which is pretty cool too. And I thought like your whole architecture, I guess, so the questions I have are probably like, one, I guess when you got to the end, it was like, oh my gosh, this thing is serverless and it's free basically, which pretty much is going to destroy this question. But why not use something like Kafka or something like that? I thought it was also a very, when you said it in the beginning, I was like, he's going to talk about Kafka. And then you went this other way.
Yeah, I mean, there are, of course, additional ways of implementing this whole thing. But as you mentioned, all the other options usually require to provision something up front, which means you pay for it no matter if you use it or not. And you also have the scalability problem. So what happens if, for example, in our use case, people do like scanning of the buckets every week, for example. So every Saturday or Sunday, they have lots of files to be scanned because they scan all the files that are existing. And then during the week, they only scan the new files. So we have peaks. And that's super hard to kind of get right with all the systems. And I think with Kafka, I think it's quite a challenge to get it right. So that's why I went this way. So the goal really was to keep this as simple as possible. And yes, there are other options, I agree. But the benefit of this option is that it scales from 0 to enough for our use case.
I mean, I love it. Honestly, I think keep it simple is a great way forward. And I wanted to know, you said something in your presentation as well about like one of those things that you shouldn't change in production. What was that thing again? Yeah,
so that was about like one problem I was running into is I had Glue running in my developer account and also in my production account. And then we kind of added additional attributes to our JSON structure of our events. And this will then, depending on how you configure Glue, this could lead to an update of your schema. So Glue will just detect, okay, there's a new column, and it will add this new column. And depending on, I mean, if you only add a column, that might not be a problem. But what about if you remove an attribute? Or what if you kind of change the data format or something like that? And then it gets a little bit tricky. So that's why I like using Glue in my developer account, and then I just copy and paste the create table statement and apply it to production, because then I really know what the schema is. Otherwise, it could change every day, every hour, no matter or how often Glue runs. Yeah.
I mean, I don't think you can get a better tip than that. So, I mean, that's some great stuff that you're telling me over there for free, right? I can feel the pain you felt in that probably before when you like were just playing around, and then next thing like this thing changed automatically. And I really liked the hack you showed with the whole UI disappearing there for a second. I thought that was really cool. Nice trick.
Yeah, that's another story. So the UI of Glue is a little bit clumsy.
I mean, myself personally, I love QuickSight. You know, I've like also used it with a lot. One of the things that always you brought it up as well. It was such a brilliant topic. It's like that Athena thing, right? It's like trying to write that script yourself is like, I've tried that JSON Serda before, whatever, how do you pronounce it? But I've tried as well. And it was just like an absolute nightmare trying to do the mapping of like things inside things. And eventually my brain like exploded and I was like, okay, I give up. Let me use Glue as well. This seems to be the only way to do it. Yeah, so I really feel that one. One cool thing though is that, like QuickSight natively supports CSVs. So if you can get JSON into CSV, that's a pretty big win.
Okay, I see. Yeah, yeah, and you can also do some nice visualizations, right, with QuickSight. So I mean, I haven't used it in this case, but I could also think of like, I mean, our customers, for example, they are interested in how many infected files they have, how many of which kind of virus they found, stuff like that. And so yeah, that's what QuickSight is for. You can like visualize it.
Yeah, and now it's added a whole bunch of cool stuff like for publishing dashboards and sharing them. So it's become a lot better like that too, because in the past, organizationally, it was like, QuickSight. But yeah, anyway, yeah. Thank you. I don't know if Angelo, you got anything you want to say to our great friend Michael here? I mean, I've really enjoyed this, and Michael, it's really awesome to have you here.
I just want to thank you, Michael, because it was really interesting. And thank you for being with us today and share this information.
Yeah, so thanks for having me. And now I'm looking forward to the other presentations.
Yeah, sure. Thank you, Michael, again.
Yep.
Okay, so let's move on with the next topic. Our next speaker is Davide Gallitelli. Davide is a machine learning specialist solution architect at AWS. His goal is to assist customers translating their business vision into technical realities through, of course, the services and the solution provided by AWS. He started develop at age of 8. 8. Or it's too early.
I was thinking, whoa.
At age of 8. Now he helps the customers innovate through the AI and machine learning.
So but I mean, 8 is still ridiculous, right? I mean, that's still amazing. Sorry. It's like,
hey, it's Angelo, hey, David.
Welcome, Davide. Thank you for joining us today.
Thank you very much for having me here. It's not that wrong, actually, that I started when I was 4. So I've worked computers since I was very young. My father is an IT specialist. So I've been with my PC since I was very, very young, probably even 1-2 years old, but not coding.
Okay. So the coding started at the age of 8.
Yeah, that's it.
Yeah, my son, I also have a small son, and I've been teaching him computer stuff too since he's been growing up. So I want to be like, no, he's a cloud specialist since he was about 1-2, right?
That's how you get people started, right? Very young.
Yeah.
Yep. That's the way. It's really awesome to have you here, David. It's, I mean, like everyone said, it's like some AWS machine learning stuff. I'm really excited to learn about this. This is probably one of my I don't know, like guilty pleasures, right? Like my hobbies away from work is loving to dive deep into the AI stuff. So I'm looking forward to hearing everything you have to say.
Okay.
I have high expectation now, and I feel the pressure a little bit.
No, please don't. Not at all. Not at all. No ways. Definitely not that.
No pressure. No pressure. If you want to share your screen.
Let me do that right now. So you can tell me if everything works all right. Should be coming up.
Yeah.
All right.
Okay, Davide, the scene is yours.
Thank you very much, Angelo. Thank you very much, David. So once again, hi everybody, for everyone who's listening or who's watching. So my name again is Davide Gallitelli. I'm a specialist solution architect for machine learning and artificial intelligence, and I cover the business in Benelux. So basically, if you're a customer working in Belgium, Netherlands, or Luxembourg, please feel free to reach out. You got my email over here, and I will be more than glad to help you out with any AI challenge that you might be facing. Or even if you want to know more about AI, just reach out. I'm usually very available. Just write me an email or write me on LinkedIn or on Twitter, but feel free to reach out. So today, the topic is getting started with Amazon SageMaker. So very often, one of the questions that one of the sentences that I hear a lot is that people say, oh yes, SageMaker, I've heard of it. So are we talking about Jupyter Notebooks on AWS, right? And I tend to reply a little bit like this meme here. So, well, yes, but actually no. Why do I say that? It's because maybe manager or serverless Jupyter Notebooks are just the tip of the iceberg. There's so much more going on with SageMaker. SageMaker has a bunch of features that have been there for the last 3 years. A lot more have been added in the last reInvent in December of 2020. You got some of those. I couldn't even fit them all in the classic image of the tip of the iceberg. But we will try to go step by step. We will try to learn a little by little what doing SageMaker means today. And first of all, one of the very first thing that it's really important to capture is to understand how you want to process your machine learning workflow. So very often, the very first step before deep diving into the technicalities is trying to understand which kind of problem you're trying to solve. Let's have an example. Maybe you've built a very nice event-driven architecture in which you've built a report, a CSV report of all these sales that you've done in the last few months or for the last year, for example, divided in a daily basis. Any reference to the previous talk is really just happens to be there, of course not. But let's what you want to try to do is that you want to try and forecast, maybe try and say, okay, what will be the sales that will happen in the coming weeks or in the coming days or in the coming months? This is kind of sort of defining a business problem that you would like to solve. And the first step into solving this is to try and frame it as a machine learning problem. So this is called a forecasting problem, a time series forecasting problem, in which you need to learn about the time series that you have, understand the patterns, understand the seasonalities, understand the features of your data. And then you want to make it into something which can be used by a machine learning process. And to be done, in order to do that, actually, the very first step is to prepare to engineer the data. So the data scientists out there really know what I'm talking about. So the idea is that you want to have some sort of a CSV input or any kind of JSON input, or maybe an image if you want to process images. You want to transform them in a way that the machine learning model actually understands and knows which way you want to go with your data, tries to understand what's the input in a way that it can process this input through what's called a model, a machine learning model. It can be an algorithm that we picked up from GitHub, from someone's GitHub. It could be a framework in which you've built your own custom model. It could be an algorithm that you bought online. Why not? Could be also an opportunity in order to get this input into the model and drive some outputs. So in order to obtain the best output possible and the best possible, let's say, metrics, the best possible KPI, which show that you actually have a value on top of your business problem, you want to try and tune your model. So usually what you do is that you try and train multiple models, define what's your objective function of the model itself, and then work your way through the different type of parameters in a way that you can obtain the best model possible. And finally, once that's done, you get actually the final phase, which is the deployment phase. You get the model, you want to put it into an instance so that people can call your model and get predictions out. So at the end of the day, what you want to do with a machine learning process is actually you give it some input, it will run some prediction, and will give it back to you. So probably you will expose it in the form of a microservice, an HTTPS endpoint, or why not? You want to embark it in a mobile application. Why not? On such as, for example, a TensorFlow Lite application, or on your phone, or your Android or iOS, or even on a Raspberry Pi running at the edge. Why not? There's so many different options today for deployment. What we actually suggest and what we see a lot of customers doing nowadays is, of course, using Amazon SageMaker. SageMaker tries to solve all of these problems. So it goes from step one, rather, not from zero. It doesn't really help you frame the problem, although we will see something in a minute here that will show you how it helps also frame the problem. But basically, it will take you all the way through the pipeline of the machine learning process. So it will help you process data, it will help you train the model, it will tune the model, as well as deployment. And it will do this in a very managed way, in a sort of an end-to-end service, helping you out. And of course, as every fan of AWS knows, it helps you to reduce costs. At AWS, we love reducing costs wherever we have the possibility to do so. We try and find a way to optimize the costs for running any kind of workload, whether it is machine learning or event-driven architectures or analytics or whatever. So if we want to have like a 1,000-foot overview of the different features of SageMaker, we have something that works really like this. So if you think again about the 4 steps that we discussed before, the preparing, the building, the training and tuning, and the deployment phase of the machine learning workflow, we can see that SageMaker has different functionalities, different features that help solve more or less all of the different kind of use cases. So whether it's something, if you want to just process your data, you want to transform your data, we have something for that. We have Data Wrangler, we have processing, but I will come back to that in a minute here. Then we have something which help you build your actual model. So if you want to write some code, if you want SageMaker to help you write some code, that's also something which is possible. And I will show you in a moment how to do that. And finally, if you want to train the model, it will give you a very separated environment from the rest of your production that will actually run just for the time you need for the training. So it will be completely cost optimized, will automatically turn off at the end of your training process, and will be used exactly just for that step of training your own model and tuning, of course. Finally, you have the deployment phase, and of course, the part that is even more important nowadays, apart from deployment, is actually the managing of a model that has been deployed, which also is handled by SageMaker through managed endpoints, through the possibility of pushing straight up into the edge thanks to Edge Manager, to orchestrating to automating the pipeline of pushing from development to production, thanks to something which is called Sagemaker Pipelines, which nowadays is really liked by a lot of machine learning engineers, or many people call themselves nowadays machine learning operations, ML ops architects. But generally, people tend to like those kind of, those are the kind of people that tend to like the orchestration capabilities and the automation capabilities. Me, myself, I'm one of the huge fans of SageMaker Pipelines, and something that allows you very quickly to move to automate all steps and to define a very appropriate, let's say, pipeline of steps in order to get to the production and to the management. Let's look at some of those features that I was alluding to before. One that I also particularly like is called Sagemaker Datawrangler. So if you're like me, you have a background, sort of a developer, but like to do some code, but very often find itself writing the same kind of code. For example, if you write a lot of code for pandas for featurizing inputs, for example, you want to transform the job column that you see here on the screen, you want to encode it, or for example, you want to transform from an integer parameter to a floating point, or any kind of transformation, which is mostly under transformation, you will love Datawrangler. What does Datawrangler do? Is basically it provides you a very nice visualization of the different steps to do preparation. Basically, you give him an input file, notably a tabular file, for example, a .csv or any similar kind of file of that way, and it will provide you, as you can see here on the right, on the column on the right, a lot of different transformation that nowadays are more or less used. For example, dropping columns, renaming columns, handling missing values, finding outliers, or for example, formatting string. A lot of people spend a lot of time writing code formatting from date time to other different formats because they then they want to use those kind of information into their machine learning pipeline. This is something that usually we write all the time, the same code. The advantage of Datawrangler is just that, as you see here, if you want to drop a column, you click, you choose drop the column, you click add the step to the rest of your processing pipeline, and it does that for you, and it will give you a nice preview and a nice visualization. So this is the first step. If you have tabular data, you will love this. If you are more of an advanced user, for example, you want to write some evolved PyTorch code, or maybe some kind of TensorFlow code, you want to use a Keras neural network which has been pre-trained to do your pre-processing, you can check out what's called Sagemaker Processing, which allows you to do those kind of transformation a little bit more evolved, a little bit more advanced. One thing I didn't say about Data Wrangler is that, of course, you can use your own custom code or custom formulas if you want to, because it allows the possibility to load some Pandas code or some PySpark code in case you want to do it on your own and not use one of the very basic and very, let's call them entry-level transformation, more known transformation for your dataset. Once you've prepared your dataset, then it's the next step. It's the part for building your actual model. If you remember, we were talking about step 2 in the previous ML framing, ML problem workflow. So when you want to build your model, very often what I found myself to do and what I find other data scientists to do is that very often they try and import data, not data, but code, models, and algorithms from the state of the art. So you see the people using XGBoost out there, which is a gradient boosting trees to do kind of classification, some kind of regression. There might be people who want to do, for example, PCA, or they want to do k-means clustering, or they want to do, for example, why not semantic segmentation? So, for example, removing backgrounds from images. We provide some kind of built-in algorithms, which have been specifically rewritten from the state of the art. So they were taken from the open source. They were put into SageMaker free of cost, so you can use them as you want. You will only pay for the underlying resources when you train. And then you can use some of those, which you would anyway use. You would still pick them up from online or from some kind of library. Or if you want to, and you've already written your script, for example, you can use your TensorFlow script, your Keras script, without having to handle the whole containers side of things, or having to spin up a specific machine, installing the libraries. You just provided up a Python script and the requirements for that Python script, and SageMaker will handle everything for you in the training step. It works for TensorFlow, for MXNet, for PyTorch. It has support for some higher level libraries, just such as Keras, Gluon-TS, generally Gluon, but in particular Gluon-TS, Gluon-CV, Gluon-NLP, etc. If you want to use scikit-learn, we have what's called an estimator for that as well. But if you want to use something a little bit more exotic, I don't know, you're a fan of Paddle, or you want to bring, for example, your very specific version of the framework, which is supported by script, but you want to choose your own and you want to load your own requirements, you can even bring your own container. So you write a Docker file and you give it as an input to SageMaker. Do you give an input to what exactly? Of course, to the training step, which is the very next step. So while you might have your managed notebooks or your serverless notebooks, or even your PyCharm environment where you do, or even the VS Code environment for all that matters, where you do your own development, instead you will have a separate environment for the actual training. This environment will be spin up by the estimator training API. So you specify, for example, the container that you want to use, you specify which kind of instance you use, how many instances you want to use as well. And then all you need to do is just call .fit, just like you would do in scikit-learn or in Keras or any other. Basically, most of the frameworks nowadays support .fit call to train the model. The idea here is that the SageMaker will spin up the instance that you specified in train instance type for you. It will spin up one or multiple of those instances according to what you specified. It will install the container that you provided, or if it's one of the scripts that I was telling you about before, so scikit-learn, TensorFlow, etc., it will load a standard, a default container with TensorFlow already installed or PyTorch already installed. Then it will copy the data on that machine and it will train the model for you. It will store the model into S3 and then it will shut down the machine. So you actually pay for the exact minute or even seconds that you run your machine. So that's a really that's a really interesting measure for cost optimization, because otherwise you will need to run like 24/7 machine for the training and you don't know, and maybe you forget about turning it off. But SageMaker is pretty kind, it does that for you, so it's an advantage for everyone. Then finally, once the model is into S3, you want to deploy it. You want to deploy it to something which is to yet another machine. So for example, you have a real-time inference endpoint, which is supported by a simple call, .deploy to the same model we trained before. And then it will spin up a machine. This time it will run 24/7. It will put an HTTPS endpoint in front of it, so you can call it either with a Boto3 SDK if you're a Python fan. You can call it straight up with a Postman, for example, if you want to use straight up HTTPS endpoint. You can hide it behind an API gateway plus a Lambda. They will handle the actual transformation of the data before feeding to the model itself. Or if you're more into the, let's say, into the batch transformation side of things, let's say you want to inference on larger size of data set, maybe you want to do something along the lines of batch transform, which is a sort of an asynchronous call for large size of data set. For example, you have your data that you want to do prediction on onto S3. You run a batch transform. SageMaker will pull the data off of S3. It will do its processing, its prediction, and write it again into S3. Or if you want to use your model wherever you want, whether it's one of the Amazon Container Services, whether it's on EC2, or anywhere you like, you can grab the model and run. You can use the model that you train on SageMaker basically wherever you want. There's no real, the sky is the limit here. But model deployment is not the last step. Actually, one of the things that most people nowadays are looking into with a lot more detail is actually what happens after model deployment, which is the monitoring of the model itself. Sometimes model accuracy can degrade over time because, for example, input data is different from the data we trained on. There might be some different features that we wanted to add. There might be a divergence in the data or in the model itself. So the idea is that SageMaker provides you something which is called Model Monitor, which allows you to actually detect those drifts. Either it's a concept drift or a model drift itself, and will, for example, send to a queue it will send a notification in SNS, or maybe it can also automatically trigger what's called a pipeline. So Amazon SageMaker Pipelines is something that allows you to build an ML workflow using the Python SDK. You can visualize it in SageMaker Studio, but you can write it basically whatever you want. It's not necessary to use SageMaker Studio. You define all the steps of your pipeline, and maybe if Model Monitor found something which is not working and you want to trigger again a new training, maybe you can just push something to an event bridge bus, just like we've seen before, and automatically pipelines will pick up these kind of events and trigger a new pipeline so you can train, debug, and optimize a new model. And if it works better than the last one, you can automatically push it in production. Why not? So heading towards the conclusion, because I see that I'm running out of time. So maybe you are looking at me a little bit like this, like these other memes. So I've said probably SageMaker around 100 times in the last, 15 minutes, 20 minutes. But what I want to understand is that SageMaker is but a tool that allows you to solve your business problems. You might be a developer trying to add some artificial intelligence to your application. You might be a real hardcore data scientist. You might be an ML engineer that was told to try and automate everything. SageMaker has a bunch of different features, and if you want to connect the dots among all of them, it will take way larger whiteboard than the one that you see in the meme here. But actually, the idea is that it will try to solve the different problems with different features. AWS, your account team, and me, if I can give you any help, we're here to help you out. So first of all, if you want to start, where do I start? If you have tabular data, CSV data, just like the ones that we've seen before with Michael, you might want to start with something which is called SageMaker Autopilot, which actually allows you to load the CSV model from S3, and then everything is done automatically by the model. You don't need to touch anything, and it will give you an output, a deployed model. Basically, it will try and detect which kind of problem you're trying to solve. For example, if you have a column that says label and it will say true or false, it will automatically switch to binary classification. If you have like real values that you want to predict the forecast that we were talking about before, that's a kind of a regression workload, and Autopilot also supports that. It has different kind of model that it trains in the background. It's a sort of auto machine learning. It's done for you. You don't need to do anything. You just need to choose your input, let it do all the training for you, deploy it, and then you can get your profit from that. It's great for stakeholders, for developer. If you have tabular data, this is the way you should go. Otherwise, if you want to pick a model from the state of the art, for example, you know that PyTorch has those amazing faster RCNN models that you want to use from the hub, Or maybe you have seen that AWS has deployed a solution which is specific, for example, to fraud detection. You might want to check SageMaker Jumpstart. Jumpstart is basically a portal in which you choose what you want to deploy, whether it's a model from one of the most known hubs, just like PyTorch Hub or TensorFlow Hub or the MXNet Zoo. You click 2 buttons and you deploy it. It's that easy. It also allows you to deploy, for example, the solutions from AWS, such as the fraud detection from graph learning. There are the ones for predictive maintenance that are also available. There are about 14, 15, even more maybe of that. So you just need to open SageMaker Studio, check out SageMaker Jumpstart. It's on a button on the left. Maybe I will have a few minutes to show it to you. And with 2 clicks, you will deploy it, and SageMaker will do everything for you. It's great if you are a researcher that want to kick off an ML project, or if you are a dev that want to see if your idea can work for that. If you're more of an advanced data scientist, once again, think about the fact that there are supported frameworks within SageMaker in this so-called script mode. So that, for example, you can load what's called a PyTorch estimator, and the only thing you need to do is you give him the script that you have already run. It can run on your PC locally, it can run anywhere basically where you have your training loop, and then you just need to call the .fit on the S3 data that you have stored. And that's it. It's that easy. Nothing more to it than that. Of course, if you want to use a container, you might need a little bit more lines and write a Docker file, but chances are that you will use actually one of the frameworks that are supported by SageMaker. And if you want to get started with SageMaker, there's actually a new SageMaker Immersion Day that you can find online. The address is sagemaker-immersionday.aws, if I remember correctly, but you can look it up online. It will be available. There's all the different features that I just talked about and even more, so feel free to check it out. And maybe even tune in for next week. There's a session by AWS Benelux, which I will host for a SageMaker Immersion Day. If you want to tune in and be part of that, why not? You're more than welcome to join. So thank you very much. This was my presentation. So here are my contacts. If you want to reach out, more than welcome to, and let me know. Thank you.
Wow, that was great, man. Sheepers, so many things. I don't know if you want to take this question here. Where can I chuck it up here? Over there, I think that's it there. So Cloud Child 1992 asks, can I use Data Wrangler with Glue? I actually don't know if, can you?
So there are different inputs into Data Wrangler. I don't remember exactly if Glue is one of the supported ones, but I know for a fact that you can use Athena. So maybe you can use a straight up, instead of using Glue, you might want to use straight up Athena. You can use standard S3 as an input, or you can also use Redshift. So it allows you to define a JDBC connector to Redshift in case you have a data warehouse. So I don't think Glue itself, it's supported. So you cannot use, let's say, a crawler, just like we've seen before with the demo. But instead, what you want to use is rather use the Athena step of the demo from before to actually import a data set to Data Wrangler.
Okay, that makes sense. I mean, even for someone like me, out of interest, I don't know. I love to tell this to like AI guys, but one of the things I saw cool as well with the machine learning stuff was the data parallelism. Am I saying that right? That was introduced. So like you can do, like you're saying, Jumpstart. It's got all these cool models. Like one of them is BERT. And you can use like BERT, which has like 100 billion parameters or something ridiculous. And you can use this managed data parallelism. Oh man, that's such a terrible word to say online. But you can use that to train these models, and like, you know, so it trains it a little bit and it actually distributes the training, as opposed to in the past where you'd have to like take a snapshot of the model and then like boot a whole machine and load it and do all of this magic. So if you're ever wondering how they do these monster trainings, this is the way and stuff. So it's really cool. I got to ask you a question. Do you ever deep race?
Oh, I don't have a deep race, but I used to play with a deep racer a lot. So there was like the whole Paris summit before I was in Paris, and we used to do like during the summit when it still was like a physical thing, we used to run like the courses. And if you check online, maybe you go to YouTube and see one of those videos from Deep Racer. There's actually a video where I'm run over by a Deep Racer. It's really fun.
Awesome, man. That's cool. Thank you so much for your time, David. I really enjoyed your presentation. It was awesome. I learned quite a few things.
Thank you, David, and thank you, Angelo, for having me here today.
You're muted, Mr. Angelo. Let's check what's happening here.
Sorry, I was talking by I was muted. So Amer has provided us the website for the SageMaker Immersion Day. So if you are interested, this is the link.
Oh, whoops, sorry. Can anyone join it? How does it work? I actually was like, oh, try to click the link like a noob. And
no, you can click the link. You can just join. Okay, so thank you, David. Thank you very much. As I said before, really interesting. So let's move on.
What's happening next? Who's awesome? Who's the next awesome guy we got coming up here?
Well,
he's going to blow the rest away. There's no way we can.
But not least speaker, it's Marek Kuczynski. I hope I pronounce it well. For those who followed our user group, Marek needs no introduction as he is an habitué of our events. For those who don't know him, Marek is a strategic account solution architect in AWS in the Netherlands. He has been with the company since last 2016 and worked with enterprise, startups, serverless customers, so every type of customer, working full-time, of course, in this role. Before AWS, Marek spent several years as a security consultant and ethical hacker, focusing more on cloud, mobile, and backend systems. So Marek, welcome. It's always
thank you so much.
A pleasure.
What a beautiful introduction. I didn't count on that.
It's a pleasure to have you as always.
All right. No, thank you so much for having me again. I'll do a quick introduction nonetheless, right, for people that maybe haven't actually seen me. But it is, yeah, I think I haven't actually counted, but it's maybe the 4th or 5th time or something like that I'm speaking for this meetup group. Yeah. And yeah, always trying to keep it a little bit fresh. You heard already a little bit from Angelo's introduction that I've done several roles within AWS, so I'm pushing again the limit a little bit with the topic today as well. So I hope you will like it from that side as well.
Now I'm excited. From my side, I must admit, that sounds cool.
Yeah, raising the bar, right? Raising the bar.
Exactly.
Okay, Marek.
All right. Cheers.
The scene is yours.
Thank you so much. So in the next 20 minutes or so, I see that my screen is well visible right now. In the next 20 minutes or so, I'm going to be talking about serverless and containers and what's actually possible today, right? Which is maybe a bit of a ambiguous title, but as I was mentioning already, I'm going to be zooming a bit in on kind of the newer serverless features that are available, and also show you maybe some of the things that you may not know that were possible with serverless yet. So it's really going to be focusing on some of the latest and the greatest features that came out. And we didn't really agree or coordinate this type of way, but I think it's also going to build nicely on David's talk, right? So he showed a bit how you can use SageMaker and how you can do some inference with that service, for example, and also model training. I'll actually be showing you halfway this presentation how you could use Lambda for something similar like that as well. So it's all a little bit connected. We didn't agree on that, but you'll see some similar concepts from the previous talks in here as well. Yeah, and like Angelo mentioned, I'm right now a strategic account SA, which means that I basically work with very large customers that are adopting AWS at big scale. In the previous meetups and actually in a couple of other speeches that I've given, I was still a serverless specialist SA. So I've yet again changed. I'm still very close to serverless, and it's still a technical field that has my passion. But nowadays, I actually spend most of my time with some of the very big adopters of AWS, which are some of our customers here in EMEA. And also you can see here, you can reach me out on Twitter or follow me, Or if you want to, you can also drop me an email later on in case there's something interesting or something that I can maybe clarify for you as well. So let's get started talking about serverless and containers. And we'll start actually with a, let me just see, my PowerPoint is being a bit difficult, it seems. I'll just do it like this quickly. So what I want to actually, many of you will be familiar already with serverless, I think. It's obviously a topic that if you've used AWS, you've probably heard about it, or you might be using it already. But to maybe give a bit of a recap, I wanted to, remind you perhaps of the announcements that came out at reInvent 2020, right? So it is 6 months ago already. Maybe you believe it, maybe not, but 6 months ago we've had this big event where we announced quite a lot of things, and there were basically three main topics there that we introduced for Lambda to basically make it more accessible. The first one that I'll be talking about quite a lot today is that we added so-called Docker support, right? So you're probably familiar with Docker. Maybe you've used it with ECS or with Kubernetes or just on your local machine. But you can actually package and run these Docker images right now on Lambda, right? So you basically have a different format available that you can start packaging and running these applications in. The other interesting feature that we also released is actually one that helps your wallet a lot, right? Or maybe the wallet of your manager who's paying the AWS bill. Because what we did is we made the billing for Lambda more granular. So what that basically means is that you now pay per millisecond that your Lambda function runs, whereas in the past it used to be actually rounded up to 100 of milliseconds. So what this will actually mean specifically for you is that you get charged exactly for what you use, even if you have maybe Lambda functions that have a lot of memory and a lot of CPU assigned to them, and they only run for example 5 milliseconds. That's the only thing that we will charge you for as well. So it gives you basically, it reduces cost, but it also makes it a bit easier to use different type of configurations of Lambda. And then the third feature that also made Lambda more accessible and actually offers more capabilities is the fact that you can now have 10 gigabytes of memory with a Lambda function and also up to 6 CPUs for the execution environment. So what that basically means is that you can have, you still can get, of course, EC2 instances that are bigger than this. But this means that you can basically put a lot of computationally heavy functionality into a Lambda function right now. You have quite a lot of memory to do things in memory if that's required. And you also, if your code, for example, supports multi-core or multi-processing, you can actually fully leverage that as well. So basically, more accessible, cheaper, and also faster. That's maybe a nice way to summarize the slide as well. Sorry, my slide seems to be not, I'll flip to them a little bit manually. I think either my keyboard broke or something else. In either case, let's move on. Also a very familiar slide, I think, for a lot of people, but maybe worthwhile to still go through. Basically, whenever you start using Lambda functions, there's, one of the concepts that's quite important there is the so-called event-driven concept. So what that means is that you actually have events, which are all type of, events that can be generated by AWS or might be coming, for example, from an API gateway. Those events happen, they generate an event message, and that then kickstarts your Lambda function, right? So basically on demand, whenever there's something on the left-hand side that happens, an object gets uploaded, a request is made, something gets put on a queue or anything else like that, that's basically what can trigger a Lambda function from starting. Now, this Lambda function can, as you'll see throughout this presentation, you're probably familiar with the fact that it can run Python, Node, Java, .NET, and all the other languages that you see on the bottom. But basically, in a very similar way, you can also start using container images for that now, right? So you have either a managed runtime or you have container images. And also as kind of like a related flavor, you could say, you can also use custom runtimes, right? So custom runtimes are basically runtimes in case you maybe have a language that's not supported by AWS or you need to have a very specific version. You can also import these so-called custom runtimes to basically, make your code run in there. And then, of course, the code in that Lambda function that can run for, a couple of milliseconds or a couple of, or up to 15 minutes. And that code can do, whatever you want it to do. It can talk to AWS services. It could talk to databases. It could even talk to things outside of AWS, such as, for example, a third-party API, right? So that's kind of the mental model of how this works. And I noticed, by the way, this is highly embarrassing that my I think either my keyboard or something else broke. So I'll kind of walk you quickly through it like this. Sorry about that for the worst PowerPoint view. But to kind of like give you a bit of an overview, so it's going to be automatically invoked. It still has a maximum duration of 15 minutes, right? So even though we've introduced this container image support, that fact didn't really change. We always kill these functions after 15 minutes for you automatically. And one of the other things that we actually do that you can start optimizing with and playing with a bit as well is that we actually pause this Lambda function. So this Lambda function can actually be in a so-called warm state, or it can be in a so-called cold state. And what that basically means is that we can automatically resume this function for you whenever you start invoking it. I'll have a bit more, this might sound a little bit cryptic right now, right? Especially if you maybe aren't familiar with warm and cold starts, but it will become more clear as we actually go into the demo and further in the presentation as well. So now to dive a bit further into, what are actually the differences between the kind of like, already known Lambda variant and between this new variant. I've drawn here kind of like how this actually looks from an operating system and from a runtime perspective. So what you see on the left-hand side is runtimes, right? So these are the runtimes that are commonly referred to as zip-based. Whenever you've written a Lambda function, in the last 5 years, you very likely used this managed runtime initially, as it was the only option that was available. And what's actually specific about this is that we manage the operating system for you. So that's the operating system that you see there on the bottom. It's either based on Amazon Linux or Amazon Linux 2, but typically you shouldn't really worry about that as a customer. Then there's a couple of function layers on top of that, where you can actually use, your own or, for example, provided source code that is typically mapped in the /opt directory. And then actually on top of that is your function code, right? And this function code, as you see also here on the slide, is limited nowadays to 250 megabytes, right? Which for kind of like standard or not too complex Lambda functions is more than enough, right? You can, of course, put a lot of code into 250 megabytes. But if you start doing more advanced things, or maybe you have very specific libraries that you need to use, maybe you'll be doing some machine learning, as I'll be showing you later, or some data crunching, then actually this 250 megabytes can be a bit of a restricting factor. Now, on the right-hand side, this is the new option, right? So this is what I was actually introduced with reInvent, with container image support. And you see that there's basically a lot less boxes there, right? So you see that we kind of don't manage the operating system for you, that you have a bit more flexibility in there. We also don't manage these function layers for you. And also the runtime, actually, so actually the part where your code is running, is now something that you can completely influence and optimize yourself. So that's kind of like difference number one, right? With container images, you're basically kind of purposely moving a bit lower in the stack, you could say. While that does mean that you do need to manage a bit more things on longer term, it does give you a bit more flexibility. And as also, I think, a pretty important and nice bonus to have, the fact that you're using container images means that you can also actually have bigger artifacts. So whereas the limit was 250 before, you can now actually pack up to 10 gigabytes of data, either code or packages or anything like that into a Lambda function as well. And to illustrate that a bit further, maybe before we move into the demo, I just wanted to show you kind of like a top-down schematic of how this actually looks whenever a request is being made. So I'll show first the example kind of how it works with a managed runtime, right? So this managed runtime could be Python, Node, Java, or any of the other ones. And basically what happens whenever you make an invocation, right? It could be through API gateway or any of the other sources that is created, is that we have a runtime API that first of all gets triggered. It basically receives the request from you. It starts looking basically for where it needs to execute that request on the Lambda control plane in the backend. And then there's basically a runtime component that kickstarts and feeds these events into your Lambda handler, right? So again, if you've written a Lambda function before, you've definitely used something like this handler before. And basically what this does is it receives the event and the context from what is being submitted. It feeds that into your code. And then, for example, as in this simple example, it would just return back and print out your name, right? So quite simple, quite deeply integrated also directly with the code and the runtime basically that you're using. And then on the bottom, what is an option that we've announced, I think, a bit over a year ago as well, is that you can augment that also with so-called Lambda extensions if you wish, right? So these are kind of like, well, actually they're extensions, right, that can do, for example, additional things for you, such as security logging or maybe performance logging, or perhaps doing things like retrieval of secrets or other values for you automatically as well, right? So you're probably a little bit familiar with this already. And then basically, again, with the container image, just to illustrate this again, you can do this all yourself, right? So it's not built in, like, for example, the layers you can add yourself. You can bundle these extensions in here as well. And basically, this is all for you to do automatically, right? So what I'm trying to say here a little bit is that you can achieve the same type of things when it comes to, for example, monitoring or doing some of the other additional extension functionality. You just need to take care of it yourself, and you have basically within that 10 gigabyte of image space, you can bundle and package all of those things automatically. Now, the question that you might actually be having is, when should I use this? Or you can maybe ask us even, why did AWS even release this? And I want to dig into basically the most common, I think, or maybe the most looked at use case right now, which is actually using Lambda for machine learning, right? So it's going to be a slightly different angle than the previous speaker had with using of SageMaker for training and inference. But basically where kind of Lambda can become very interesting, I think, for this purpose, is for the fact that it is pay as you go, right? So you saw me already mention that you're now paying for per millisecond of granularity. You can also configure these Lambda functions with, having very little memory or up to 10 gigabytes of memory available. So, if you can actually figure out how to put one of those models that you've maybe trained with SageMaker, put them onto a Lambda function and use that for inference, you might actually be cheaper in many cases, right? Depending a bit on the pattern I should say the frequency and on the pattern basically of how the requests are coming in. It can in some cases also be faster, right? And why do I say faster? It can be faster because the cold start, for example, of a Lambda function is typically in the matter of seconds, right? Sometimes less than a second, sometimes a couple of seconds, which of course, for your use case could also be faster than, for example, spinning up additional SageMaker capability or doing this yourself on EC2, right? And again, not to make any enemies or to set the misconception here, it's all very dependent, right? Probably if you're doing a lot of machine learning or you're doing it with very predictable or consistent volume, you're probably going to be doing that with SageMaker, right? That's what, for example, those GPUs and those Inferentia chips are created for. But for a hobbyist like me, who has, for example, periodic inference of what I'm doing with my models, this is actually a very interesting option to use. And for the demo that I'll be showing you actually in just a minute, I'll be basing it, I'm not as smart as Davide to be able to train my models. I can only, kind of tinker with them and maybe pick up some of the pre-trained ones. And one of the websites that I actually like to use for that quite extensively is called Hugging Face, right? So let's actually go over to Hugging Face, and I'll start a little bit the demo and showing you how this actually works. Just by showing you a bit how you can actually find these models, start packaging them with CDK or with Terraform, and then actually how you can start doing inference or basically invoking these models as well. So one of the super helpful sites, as I was mentioning already, has been Hugging Face. So it's called huggingface.co. You can take a look there yourself. And one of the very nice things actually that this company does is they provide a lot of pre-trained models, right? So if you take a look at the overview that they have over here, you can see that there's over 9,000 models that are available. You can also see on the left-hand side that they have models, for example, for text generation, translation, question answering, summarizing text, and those type of things, right? So you can see that there's quite a lot of models in here with different type of purposes, where you can actually start using them based on PyTorch or based on TensorFlow, right? Again, Davide is the expert here, but these are some of the very commonly used actually machine learning frameworks that we see our customers use. Now, one of the models that I actually used for the demo is one of the distal BERT models that you can actually find on the page as well, right? So you will actually see on Hugging Face itself that there's quite a lot of models that are based on BERT, right? It's a very common machine learning model that has been refined actually by quite a lot of companies. So you'll find results here from Microsoft, from Facebook, from Google, and a couple of other companies as well. And what this model actually does is it can take a piece of text, like for example, the sample one that you see over here. I like you, I love you, right? That's a great example. And what it actually does is it kind of analyzes and gives you the sentiment back, right? So whether this was a positive or a negative answer, a piece of text actually that was given in here, right? You can of course take a look, for example, after this meetup and start playing a little bit with this model. They have this very helpful overview over here where you can actually start to, tinker a little bit with these models and start figuring out what is the good model for you. So that's kind of like the machine learning part, right? This is basically where my knowledge is also, as far as my knowledge limits, that I can select these models and I know how to start using them. What I'm a lot better at actually is how I can actually start using these in a serverless type of way. So after this meetup, if you do want to take a look at how this actually works and how this demo, for example, works end to end, you can take a look at my GitHub. I have a CDK project there available. I also have something similar available in Terraform, where I actually bundle the fully created Docker file, which I can actually show you perhaps over here. You can basically see the Docker file that I used to create this Lambda function. It also includes the process that is used there to upload it towards AWS, to basically install it and configure it within Lambda. And basically, after deploying this template, you will be able to use and start inferencing two of these common models that do something with text. So to take maybe a little bit of a look at the Docker file, people that have maybe worked with ECS or EKS are going to be bored probably by this, but for us Lambda folks, this is new, right? As it was a capability that wasn't before. What we're actually doing over here in order to create this Lambda function is that we download the machine learning model. In this case, it is actually a PyTorch model that is roughly 250 megabytes in size, right? So those 250 megabytes could sort of fit in the previous or kind of like in the managed runtime sample that I was giving you before. But these models can actually also very easily be, gigabytes in size. So I have a small example actually on my repository and also a bigger one that you can start playing with. And basically, once I do my CDK deployment, which I'll skip a little bit given the limited time we have today, what I will end up with is a Lambda function that is actually automatically created for me. So I've called this stack CDK ML, right, just to give it a bit of a friendly name. And we're going to be looking at the so-called Distelberg model, and basically taking a bit of a look if I can, recreate this text classification that I was showing you before on their website within Lambda itself. Now, before we do that, it's maybe interesting to point out a couple of the differences, right? So what is actually different with this container mode? Now, the first thing is actually that, you can see it's already a little bit spoiled over here. There's not really a code preview available, and there is actually a link towards an ECR repository, right? So ECR is the container repository service that actually at AWS we've had for already a couple of years, right? It's used by ECS or EKS in case you have maybe container images that you need to upload. And in this case, actually, you can see a couple of the containers that I've uploaded automatically with CDK, right? CDK will actually automatically create this repository for us, create the Lambda functions, and basically merge them together. And you can actually see that, these images, in this case for machine learning, they are between 700 megabytes and 1.8 gigabytes in size, right? So especially the 1.8 gigabyte in size is, significantly bigger than what you could be doing on Lambda before. So this is actually one of the prime reasons that this mode is so interesting as well. And to maybe actually show you that this works as well, now that I've shown you the ECR repository and how that works, I can just, I'll simulate it over here. You can see in my overview that I've connected this Lambda function up onto an API gateway. Again, I could do this basically with synchronous sources on AWS, with queue-based services, or whatever other integration that is available. But in this case, maybe for simplicity, I'll just, feed in a event string directly from the Lambda console and basically see what type of prediction the model will give me back. So what I've entered over here, I hope it's good enough to see for you at home, depending on how big your screen is. I've added just the text, right? It could be, let's say, for example, something like serverless is awesome, right? Let's see what this model actually thinks about this. Now, the initial invoke will probably take a couple of seconds because I haven't actually pre-warmed this Lambda function. It actually needs to fully recreate it. And we can see actually right now that it successfully ran, right? So it took approximately 10 seconds to run. And what it actually responded back, that's maybe the most exciting part actually of this demo, is that this is actually a positive text, right? So this machine learning model is 99% sure, probably because I use the word awesome and those type of things, that this is a positive text. If we, for example, change it, just to show you that this is not smoke and mirrors, but something that hopefully will work. If we change it to serverless is not awesome, right? I don't know why you would say that, but some people might think that. You will actually see that it ranks it as negative, right? So it's at this point in time, 99% sure that it's a negative text. So, this is kind of like just to show you a little bit that this machine learning model works. What's also interesting, I think, about this, maybe just to highlight, that you can do quite powerful things with these Lambda functions nowadays, is that we've used approximately, this was a Lambda function that I've actually configured with 2 GB of memory, which means that it does have 2 CPUs available. And in this case, actually, it consumes something like a gigabyte of that, right? So something like half. And actually, once the function is warm, it takes only 49 milliseconds. We can run it a couple of times again, right? But you will see that it runs approximately between 40 and 50 milliseconds every time. You can actually see that once this Lambda function is warmed up, right? So it means that basically it's in cache with AWS. It actually performs rather fast, right? So what I'll spend, and I see that we're nearing the almost the end of the time, so I'll speed up a little bit. But what is probably the kind of like the takeaway for whenever you start doing this is that for these type of synchronous invocations, wherever you have maybe, you're dependent on very quick requests and responses, right? So especially if you put, for example, such a model behind API gateway, you probably would want to either, make sure that it's always warm, right? So that it's always invoked and always in cache and always good to go. If that's actually a problem because you maybe have very spiky or unpredictable traffic, you could use something like provision concurrency to actually automatically keep it in memory and make sure that it's always performant and always gives you that nice, 40 to 50 millisecond response back time. In case you're actually using it with maybe a queue or a stream-based invocation, so maybe you actually have messages that are put on SQS or on Kafka or EventBridge or any of the other kind of asynchronous event sources that we have, in that case, it's probably less of a problem for you, right? So you still want to monitor and make sure that you don't have, very many cold starts, because at the end of the day, it does impact the end-to-end processing time that you have available. But it's probably less of a concern for you as we actually handle that challenge and response and those type of things automatically for you in the background. So I did have a couple of more things to share, but I see that I'm just basically speaking too much as always. So what I'll do right now is I'll just switch over very quickly to the kind of like additional reading and further reading links that I can encourage you to take a look at. So in case you actually want to take a better look at the CDK demo that I was showing you before, it is available on my repository, right? So we'll link it perhaps on YouTube, or you can just take a screenshot right now and visit the repository if you want to. I also have created something similar, not including the machine learning sample, but also for Terraform, right? So I do realize that, of course, not everyone is maybe using CDK or maybe using SAM. You can achieve the same thing basically also with Terraform. So there's also a sample available on my GitHub for that. And last but not least, I would also encourage you, if maybe I sparked your curiosity a little bit with this, and you would like to actually understand a little bit better how this actually works, how you could start leveraging and maybe doing machine learning or other cool, use cases that weren't possible with Lambda before, I would also encourage you to take a look at the AWS blog, at some of the documentation, or, if you cannot find it there and would like to ask me directly, you can also take a look here at the contact details and reach out to me directly. So with that being said, I'm purposely trying to stay within the time. Thanks a lot for attending. I hope it was useful and hope I've given you a little bit of an idea what you can do with Lambda and containers in 2021. I hope there's a couple of questions, and thanks again for listening and attending the talk.
Thank you, Marek. Thank you very much. As always, really interesting topic.
My mind is blown, man. I'm like, wow, you did all of that with CDK and Terraform. I definitely want to check that out too, actually. Like, that could be really useful, right? So I'm definitely going to take a look at that stuff. Really cool, man. Yeah, awesome.
Sure, great. Good stuff.
Yeah, I saw that there is only one question from CloudChild 1992. What was the GitHub URL for the code? So
and I see we posted it, right?
This one.
There we go. Man.
Wonderful.
Good job, Angelo.
We are prepared.
Wonderful,
Okay,
wonderful.
Really cool.
There is no other question. Sorry, David, go ahead.
No, yeah. I was just wondering, I don't know, like, I think as well there's a way to like kind of deploy stuff with like SageMaker 2 to Lambda, right? If I'm not mistaken. Is that possible? Do you know if that's possible? Like SageMaker Neo or something, right? I think. You know?
I wish Davide was here. He would. I'm less familiar with the SageMaker side of things. What I can share with you, and there are some containers actually being used within SageMaker itself, right? So it does make use of container itself as well. What I've actually done in this case is, you could pick up basically the binary that comes out of SageMaker that you're using to train. And basically that's kind of like the entry point that I have here, right? So I'm not 100% sure if you could maybe do a shortcut with reusing the container or something like that. Haven't actually seen it. It's at the end of the day, basically that's .bin, PyTorch.bin or whatever it is. That's the one that you actually want to have and fiddle into the Lambda function. Maybe as a bit of a teaser, I know we don't have questions. There will be more samples and actually more documentation coming out for this as well, right? So we've had a couple of customers that have been pioneering with this, sometimes successfully, sometimes with a lot of frustration or a lot of things that they had to basically overcome, right? But actually from AWS side, you will see more information about this, more samples, basically more guidance. So if it is, always feel free to reach out to me. But yeah, I can also give you maybe in private a bit of an overview of what is coming out. And I'd love to also engage actually with folks that are curious about this area, either as hobbyists or professionally, and basically get a bit of the feedback of how we could do a better job as well in this new field.
Well, I mean, that cool thing of like having that model, like going to that random place and meet like Hugging Face and be able to use like some other model, like just kind of bundled together with all of that cool infra, that structure, IAC stuff that you've written. I think that's really awesome. So many times you read these articles, you go through the whole thing and then you're like stuck there trying to put it together, but you just like created that one button, which is super nice. So thank you so much, Marek.
Actually,
awesome. Cheers.
Actually, we have Davide can reply to this question. So let me head to the stream.
Oh, is he still here?
Yeah.
Oh no, we have the actual machine learning guys here.
Actually, Marek, your topic was so interesting. How could I miss it at all? Like, it was very interesting topic. So thank you for sharing that.
Sure thing.
So just to go back to the question that you asked, so if it's possible basically to push from SageMaker to Lambda, maybe through Neo or something, at the moment, Neo does not support Lambda runtime as an actual target, so you cannot compile a model to Lambda. However, and here I can do some free publicity to my own GitHub, there's like a project that can help you push through CDK actually to a Lambda from SageMaker. So one of the Sagemaker pipelines basically allows you to train the model itself, push it to S3, and then there's also a part of another pipeline which takes the model from S3 and push it to a Lambda function through CDK. So basically in the background it uses code pipeline and code build to do that, to build a container and to push it to a Lambda. But if you want to check it out, it's part of what's called a Sagemaker project, which is basically a wrapper around continuous integration and continuous deployment. But you can use that to push to Lambda if you want to. So Marek, we could do a collaboration on that. It could be interesting.
Yeah, we need to talk, I think, right? It's good that we met.
That sounds pretty
we're
awesome.
part of the same company. We've met here in this meetup, I guess. So we'll connect. Maybe we'll give a talk together someday. Who knows, right? Once we've solved all of this.
With incredible pleasure.
Okay,
Awesome.
if there is no other question, thank you again, Marek. Thank you again, Davide. And with Marek and Davide, we will close this event. I would like to thank all the speakers again, Michael, the first one, Davide, and Marek for being with us today. I would like to thank you also, Zamira Oyaupai, who worked behind the scene for the realization of this event. Of course, I want to thank you, David, to be here with us. And you people that follow this event, stay updated with our website because other events are coming. And thanks again for joining us. See you at next event. Stay safe. Ciao.
Cheers. That was pretty fun. I had a